Let's try to do this very quickly. Question number A. Find an equation of the tangent to the ellipse at this point and show that the tangent can be written like this. Okay, we need the gradient first. So we have y, so this time we don't have t, we have theta. So dy by d theta. So 4 sine theta would be 4 cos theta, and dx by d theta, 5 cos theta would be 5 minus cos theta, so that means minus 5 cos theta. So therefore dy by dx would be dy by d theta divided by dx by d theta, so 4 cos theta divided by minus 5 cos theta. Derivative of cos theta is sine theta, this should be minus sine theta. Okay, minus sine theta, so minus 4 by 5 cos theta by sine theta. Okay, so the point that they are giving, this is a Cartesian point, by the way. Every time they give a point, it's a Cartesian point. So the point that they're giving is 5 cos alpha. So at x equals to 5 cos alpha, so let's put it here. 5 cos alpha equals to 5 cos theta. Therefore cos theta equals to this 5 and this 5 cancels. Cos alpha, so instead of cos theta I can write cos alpha. Then it's written the y code. Remember, this point is a Cartesian point, so at y equals to 4 sine alpha, so I can put it here. So 4 sine alpha equals to 4 sine theta, so therefore sine theta equals to sine alpha. So all I have to do now, let me get back here, so therefore dy by dx equals to minus 4. Instead of cos theta I can write cos alpha now. 5 instead of sine theta I can write sine alpha now. So that's dy by dx in terms of this. Now we have to find the equation of the tangent. So at gradient of tangent equals to minus 4 cos alpha divided by 5 sine alpha. Now equation. So equation, we need a point. Now this is the Cartesian point, x coordinate and y coordinate. So what we have to do is y minus y coordinate. So the y coordinate is going to be 5 sine alpha, 4 sine alpha. So y minus 4 sine alpha equals to, the gradient is minus 4 by cos alpha divided by 5 by sine alpha. And then we have x minus x coordinate, which is 5 cos alpha, 5 cos alpha. So now we have written it like this. Now they're telling us to simplify this. So if you simplify this, so y into this would be y into 5 sine alpha minus 4 sine alpha into 5 sine alpha equals to, now upstairs into x, this is going to be minus 4 cos alpha into x minus minus plus 4 cos alpha 5 cos alpha. Let's simplify this. This would be 5y cos alpha minus 5 4 is 20. This would be sine square alpha. This would be minus 4x cos alpha. This would be 20 cos square alpha. This would be 5y cos alpha, and if I bring this to this side, this would be plus 4x cos alpha. If I bring this to this side, this would be 20 sine square alpha plus 20 cos square alpha. So 5y cos alpha plus 4x cos alpha. I think this was sine alpha, I wrote cos alpha. Okay, If I take 20 common, this would be sine square alpha plus cos square alpha. So we have 5y sine alpha plus 4x cos alpha. The identity sine square theta plus cos square theta becomes 1, so this would be equals to 20. Okay, did they tell us to show this? 5y sine alpha plus 4x cos alpha equals to 20. Yes, we have shown this. Now in question number B, find by integration the area enclosed by the ellipse. Okay, this shape is called the ellipse. So now in order to find the area enclosed by the ellipse, we have to integrate the ellipse. Now in order to find the area under the ellipse, we can do one thing. If you think about the ellipse, it's starting here and going all the way and ending here at 2 pi. So you can think of this ellipse as the limit being 0 to 2 pi. So this is a sum that it's a difficult sum, you need to remember. Starts at 0 and ends at 2 pi. So the Cartesian would be area equals to limit x1 to x2 y dx. So the limit here would be theta equals to 0 because it's a complete circle. So theta equals to 2 pi. So we have the limits now. So the first thing that we need to know after the limit is dx. So x equals to 5 cos theta. So derivative of x is dx by d theta. This would be minus 5 sine theta. So therefore dx would be minus 5 sine theta d theta. Hence now we can do the substitution directly. Area equals to, lower limit is 0 to 2 pi. So we have y dx. The y is 4 sine theta. So 4 sine theta, and dx is minus 5 sine theta d theta. So if we simplify 0 to 2 pi, 5 4s are 20, so minus 20 sine squared theta d theta. So what that means is we have to use the identity. Now one thing that we can do here is we can reverse this 2 pi to 0. Remember, when you reverse the limit, it becomes positive. So we always integrate sine square using the identity. Cos 2 theta is 1 minus 2 sine squared theta. So 2 sine squared theta is 1 minus cos 2 theta. Therefore sine squared theta is 1 minus cos 2 theta divided by 2. That means 2 pi to 0, 20. We can write 1 minus cos 2 theta divided by 2 d theta. So if you cancel this, 2 tens are 20. So 2 pi is 0. This would be 10 ones are 10 minus 10 cos 2 theta d theta. So now if we integrate, 10 is going to be 10 theta minus 10. Integration of cos theta is going to be this divided by 2, chain rule. So 2 pi is 0. So 2 5s are 10. So if you put the limit, 10 zeros are 0 minus 5 sine zeros are 0, so that means 0. Now if you put 2 pi, 10 into 2 pi minus 5 sine 2 into 2 pi. So this is 0, 5 zeros are 0, so this is 0 minus 5 to the 10, 10 to the 20 pi minus sine 4 pi. Now it doesn't matter what is 2 pi or 4 pi, it means it is just rotating here. So sine 2 pi is 0, that means sine 4 pi would also be 0. This is 0. So the answer is minus 20 pi. Now the area shouldn't be negative, it should be positive, so I'm looking for the mistake here. Where is the mistake? Here's the mistake. I cannot find the mistake here, but anyway, the answer is correct. So the answer is area equals to 20 pi. So you have to you have to do the calculation yourself here, so it should be 20 pi. So in question number 3, what we have to do is we have to find the area of this region, the remaining region here, the region between the parallelogram. When you remove the ellipse from the parallelogram, whatever is remaining, so this region, we have to find the area. Now if you want to find that area, what you need, area of the region equals to area of the parallelogram minus the area of the ellipse. We already know area of the ellipse is 2 pi, so this is 2 pi. Now if you find the area of the parallelogram, then if we remove this from this, we'll get the remaining area of the region. So for finding the area of the parallelogram, all we have to do is find the area of one of the parallelogram, one of the triangle subscribed by the parallelogram, and if you multiply by 4, we'll find the area. So for that, we need, where does this line cut the y-axis and where does this line cut the x-axis? That's what we need. Now in order to do that, we can use this equation of the tangent. It's given, we just prove this equation of the tangent. So this is a tangent. So what we can do, we can write for question number C, let me copy the equation of the tangent. 5y sine alpha plus 4x cos alpha equals to 20. So this is the equation of the tangent. So where does the tangent cut the y-axis? So at y-axis, x equals to 0. If I put x equals to 0, it would be 5y sine alpha equals to 20. This term becomes 0. Therefore y equals to 20 by 5 sine alpha, so it will be 4 by sine alpha. Again, now we want to find where does the tangent cut the x-axis. So at x-axis, y equals to 0, so we can put y equals to 0, this thing becomes 0, so it will be 4x cos alpha equals to 20. Therefore x equals to 20 divided by 4 cos alpha equals to 5 cos alpha. So now we have the value of x and y, where does it cut the x-axis and y-axis. So if this is the origin and it cuts the x-axis at 5 by cos alpha, and if it cuts the y-axis at 4 by sine alpha, then we can find the area of the triangle here. So area of parallelogram is 4 times one of these triangles, because there are 4 triangles. So one of the triangle has the area half into base. Base is from 0 to this is 5 by cos alpha, and 0 to this, the height is 4 by sine alpha. So we can write 4 into 5 is 20, 20 into 4 is 80, and 2 sine alpha cos alpha. By using the double angle half angle formula, 2 sine alpha cos alpha can be rewritten as sine 2 alpha. So we have found the area of the parallelogram. Therefore area of region that we are looking for is area of the parallelogram 80 divided by sine 2 alpha minus the area of the ellipse, which is 2 pi. We found it before, and this is shown.